Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about transfer function. This is linear control systems, lecture series on linear control systems, lecture number 10. So our new topics, transfer function. What is transfer function? Why transfer function? Advantage of transfer function, disadvantage of transfer function. This is our target. So what is the overview? What is transfer function? Basic idea of transfer function. Idea of cause and effects. Input-output relation of transfer function. Properties of the transfer function. Transfer function versus transfer matrix. Advantage of the transfer function. Disadvantage of the transfer function. Types of transfer function. Limitation of transfer function. General transfer function. Poles and zeros of the transfer function. This is our target. So what is transfer function? What is transfer function? Definition of the transfer function. The transfer function of a control system is defined as the ratio of the Laplace transform of the output variable, that is response or effect, to the Laplace transform of input variable. This is excitation or cause, assuming provided that all the initial conditions to be zero. This is the definition of the transfer function. That means Laplace transform of the output. Laplace transform of the output, ratio of the Laplace transform of the output variables to the Laplace transform of the input variables. And this is the very important part, all initial conditions to be zero. So this is the definition of the Laplace. This is the definition of the transfer function. By another definition, what is the another definition or symbolic form? Transfer function equals to Laplace transform of output divided by Laplace transform of input, and provided all initial conditions are zeros is called transfer function. Another form, transfer function equals to Laplace transform of output response or effects divided by Laplace transform of input variables or excitations. This is also called cause, and provided all initial conditions to be zeros or all initial conditions are zeros is called transfer functions. So transfer function can be represented as a block diagram as shown in figure 1a, 1b, and 1c with the input or excitation on the left hand side and the output or excitation effects of the on the right hand side, and the system or planned process transfer function inside the block. So this is the systems or planned. What is the definition? This is a systems, plant or process. So this part, systems or planned. This is the inside of the block, inside of the block. And this is the input or set point, or this is also called excitation, and this is also called cause. And this section, output section, and output section, this is the effects. This is the open loop transfer function. So input or excitation, this is maybe step, ramp, parabolic, impulse, sinusoidal, analog input, digital input, any type of input you can apply. And this is the systems or plant. And this section, this is the output or effects. And block diagram by symbolic form, input equals to R of T. This is the input section. So input or excitation, this is the R of T. and gt equals to transfer function. This is the plant, this is a system gain or plant or process gain, and another section output or controlled output C of t. C of t, this is the output or effect section. This is the control output. So this block diagram, system in time domain. This is the time domain block diagram. And this is the Laplace domain block diagram. So G of S, plant gain or process gain, and input, this is the R of S, and this is the controlled output C of S. That means Laplace transform of R of t equivalent to R of S, and Laplace transform of G of S, G of t equivalent to G of S, and Laplace transform of overall output equivalent to C of S. This is the block diagram for frequency domain and systems in Laplace domain block diagram. So already discussed, this is the open loop block diagram. RT is the reference input, GT is the system gain, and CT output of the systems. So system in time domain, and this is the frequency domain where input equals to R of S and output equals to C of S and gain equals to G of S, and where S equals to what? S is equal to sigma plus J omega, sigma plus J omega, where sigma equals to real part and J omega equals to imaginary part. Already discussed sigma units Nipper and omega units rad per second, rad per seconds. Then this is the systems in Laplace domain. So Laplace transform of R of t, Laplace transform of R of t equals to R of S. This is the Laplace time domain. This is the frequency domain. Again, Laplace transform of output Ct equals to C of S, and Laplace transform of gain G of t equals to G of S. This is the frequency domain. If G of S be the transfer function of the systems or plant or process, we can write mathematically Laplace transform of G of t equals to G of S equivalent to Laplace transform of output. This is also called Laplace transform of Ct. This is the output, and divided by Laplace transform of input, and this is also Laplace transform of input, means Laplace transform of R of t, excitation. That means this is the cause part or excitation part, and this is equivalent to, and all initial conditions zeros, provided all initial conditions are zeros, zero. So another definition, what is the Laplace, what is the transfer function? Laplace transform of output divided by Laplace transform of input. This is the time domain block diagram. This is the frequency domain block diagram, and output CS, and this is the input R of S and G of S system gain or transfer function. So G of S equals to C of S output divided by R of S, and provided all initial conditions are zero. So this is the definition for transfer function. This is the G of S, this is the system gain or plant gain, and this section, input section, this is also called set point or reference input, and this is the system output, this section system output. So Laplace transform of output divided by Laplace transform of input, provided all initial conditions are zeros, is called transfer functions. The system input may be regarded as the cause. So this is the cause, or RS or RT is cause, and the plant or process output as the effects. So this is the effect section, cause and effects. The block diagram is unidirectional since the effect cannot produce the cause. This is the unidirectional. That's why effects cannot produce the cause. This is also very important sentence. Properties of the transfer function. What is the properties? The properties of the transfer function are given below. Number one properties, the ratio of the Laplace transform of the output variables response or effects to the Laplace transform of input variables or excitation. This is also called cause. Assuming that all initial conditions to be zero is known as transfer function of a control systems. This is the number one properties. And number two properties, for any control systems, there exists minimum one reference control input signals, which is known as excitation or cause, and its controls through a transfer operation, that is the transfer function, to construct an effect resulting in controlled output or response. This is the second properties, and transfer function cannot be defined for nonlinear systems. It can be defined only for linear systems. Linear systems means obey the superposition formulas, or nonlinear system does not obey the superposition formula, that is additive properties and Ohm's law, etc. Properties of the transfer function. The transfer function of a plant, process, or systems does not depend on the input to the systems. Another properties, thus the cause and effects relationships between the plant output and input is related to each other through a transfer function. Transfer function basically signifies the relationship between the output signals and the input signal already discussed for and possible input values of a control systems. Another property, stability can be determined from the characteristics equation. This is the characteristics equation 1 plus GS SS, where GS equals to system gain and SS equals to feedback element. And 1 plus GS SS is called characteristics equation, and this characteristics equation gives the stability of the systems by using, suppose example, by using pole zero conception. If all the poles and zeros left hand side of the S-plane, then system will be stable. One examples. Then another properties, from block diagram, the arrows are represents the various input and the output signals. This is also discussed from block diagram. The arrow always represents the input or output. And properties number 9, the transfer function of a control system is the Laplace transform its impulse response under assumption of zero initial conditions for impulse response. This is for impulse response. The differential equation can be obtained by replacing complex variable s with linear operation d equals to ddt. Suppose for second order system, d2 by dt2 equivalent to s square. Similarly for d3 by dt3 equivalent to s of q, s cube. This is the form. In case of engineering purpose, a transfer function, also known as system function or network function. The concept of transfer function is applicable to single input, single outputs, SISO systems, linear time invariant systems. This is also important. This is applicable for SISO systems, single input, single output systems, on linear time invariant systems. Transfer function versus transfer matrix. This is also very important concept. What is the transfer function and what is the transfer matrix? Transfer matrix basically for matrix related. This is applicable for state space analysis. By definition, transfer function equivalent to what? Transfer function equals to Laplace transform of output divided by Laplace transform of input, and all initial conditions are zeros. This is called transfer function. But transfer matrix, the matrix relating Laplace transform. This is the matrix relating. This is the very important matrix relating Laplace transform of output. That means this part, Laplace transform of output to Laplace transform of input of state space representation. This is the state space representation form of control system is known as the transfer matrix. So what is the definition? The matrix relating Laplace transform of output to Laplace transform of input of state space representation of control system is known as transfer matrix. Limitation of the transfer function. What is the limitation of the transfer function? The foremost limitation of transfer function is that they can used only for linear systems. That means obey the superposition formulas or Ohm's law. Even though numerous of the perception for state space modeling and analysis spread to nonlinear systems. And another limitation, there are only limited extension of the ideas to the nonlinear system. So these are all limitations of the transfer functions. So thank you.